Okay, so today we are doing 7.2, and we are going to use addition and subtraction properties to find exact values, and then we're also going to do some more proving with the identities. Okay, so this section is just called the addition and subtraction formulas. Oh, so I typed them in and I said write them in there. Well, I already did that for you. So I typed it in there. You are going to have a formula sheet, so you won't have to memorize the addition and subtraction formulas, but we're just going to look at them to familiarize ourselves a little bit. So if you have the sum of two values and it's sine, this is your pattern. Sine, cosine, cosine, sine. Notice that they are using the s and the t. Okay, for cosine, 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 minus sine, sine. So you'll see some similarities between these. Okay, and you will be able to use your sheet to look those up. There are some rare cases where when you're doing the tangent can be an undefined value. If that happens, then you are going to have to use the sine of s plus t divided by the cosine of s plus t. Okay, so in that rare case, you would have to use the sine sum, okay, the addition formula divided by the cosine addition formula. Or if it was subtraction, you would use the sine subtraction formula over the cosine. Oops, this will be s minus t. Okay, so the sine of s minus t over the cosine of s minus t. Okay, and that happens because tangent can be undefined, or you might get like 0 in the denominator there. So if you get a 0, that's going to be your second option. Okay, and then you can prove those formulas. The book does that for you using what we know about the unit circle. And then when you go to your homework today, you can check that out on page 500. So we're going to use these formulas to find the exact value of the expression. So here are your steps for completing that. You want to choose two numbers that add or subtract to the degree or the radian value. So when it says choose two numbers, you're going to choose two values that are on the unit circle. Now, if they give you a value in degrees, you need to keep it in degrees. And then if they give you a value in radians, you need to keep it in terms of radians. Okay, you're not going to be switching those. And then you're going to use the corresponding formula from that chart above and substitute your values in for s and t. You're going to evaluate using the unit circle. And then sometimes you have to simplify or rationalize to keep it as the simplest exact value. Okay, so there's no decimals, okay, no rounding, but you do have to simplify your fraction, okay, because you need an exact simplified value. Okay, so the first one is the cosine of 15. So what you have to determine is what are two places on the unit circle that are going to give you the value of 15. Okay, so there's nothing that we would add to, we would want to subtract. And there are several different places where you can subtract and you can get 15. Generally, if you can use the first quadrant, that's going to be the simplest for us to do, right? Because this is 30 degrees, this is 45 degrees, this is 60 degrees. Okay, so there's nothing I can add to get to 15, but what can I subtract to get to 15? What two numbers can I subtract to get 15 degrees? Yeah, so you could do 60 minus 45. What else did you do? 45 minus 30. Okay, so there's multiple different ways to do this. You will get the same simplified answer here. Okay, I did 45 degrees minus 30. Okay, and then we're going to use our subtraction formula. So it's the cosine of s minus t. So if we look above, we can see that means you're going to do the cosine of s times the cosine of t plus the sine of s times the sine of t. Sometimes I put those in parentheses because the s and t are a little confusing sometimes. All right, so then let's go ahead and do our substitution. I'll just write it here so it'll be underneath it. Okay, so the cosine of s, in this case, your s is 45 and your t is 30. So we're just going to plug those in. So cosine, cosine, plus sine, sine. Sometimes I write it like that because it's quicker for me. Okay, so 45 and 30, 45 and 30. All right, so we wrote the formula, we chose those two numbers, wrote the formula. Now we need to evaluate using the unit circle. Okay, so on the unit circle, the cosine value at 45 degrees, can you guys tell me what that is? Do you guys remember? The cosine relates to the what? X, yep. So the point is root 2 over 2, root 2 over 2. Okay, so you're going to have root 2 over 2. And then the cosine at 30. Okay, so we just need to know that first quadrant. You can write that on your paper if you would like to. Okay, so for here you have root 3 over 2, 1/2. Okay, so your cosine is going to be root 3 over 2. And now we're going to the sine. So the y-coordinate at 45 degrees, we just plug those in and then go ahead and simplify. Okay, so Elliot, what's the sine at 45 degrees? Yep, so that's what you should plug in there. And then tell me what you get for the sine at 30. 1/2. Great. All right, and now we're just going to simplify. So we're going to multiply those together. So, Ilaria, what do we get when we multiply those two? Yep. Okay, and then Zoe, what do we get when we multiply these? Root 2 over 2. Yep, and then you can either leave your answer like that, or you can just write root 6 plus root 2 over 4. Okay, if you ended up with root 2 plus root 6 over 4, that would be the same thing. All right, questions for me on that? All right, so that is degrees. Now we're going to work with some radian values. Okay, so if you look at your first radian, you have 7 pi over 12. So you want to find two values that add up to 7 pi over 12. Okay, because we have the pi over 3, the pi over 4, the pi over 6, in order to translate that to a denominator of 12, I always find it helpful to take that first quadrant and convert so that you can look and see which ones add to 7. Okay, some of you might not have to do that, and that's okay. Okay, but with your radians, sometimes it's easier to convert those values of the first quadrant so that they all have the same denominator. Okay, so if you have pi over 6, we're going to convert that over 12, over 12, over 12, over 12. Okay, so 6 times 2 is 12. So pi times 2 is 2 pi. Okay, we can convert the rest of those, and then I want you to choose 2 of them that add to 7 pi over 12. All right, and then you guys should be able to find 2 that are going to add. Let's make sure we did our conversions correctly. So Nina, what did you have for the numerator here? Yep. All right, and then Marjorie, what did you have for the next numerator?
4 pi.
Yep. And then your last one is 6 pi. Okay, so if you're trying to get to 7 pi over 12, you can see you have 3 pi over 12 and 4 pi over 12. Does not matter like what order you put them in, okay? So when we write this, we're going to write the reduced forms, okay? So it's the 3 pi plus 4 pi that equals the 7 pi over 12 because you keep your denominator the same. Okay, so instead of 3 pi over 12, okay, you can write that as pi over 4. And instead of 4 pi over 12, we're going to write it as pi over 3. Again, it does not matter if you do pi over 4 plus pi over 3 or pi over 3 plus pi over 4. Okay, and then we're going to use our tangent, s plus t. So it's the tangent of s plus the tangent of t. Okay, so based on that formula, let's go ahead and plug those in. So I'm using my s is pi over 4, my t is pi over 3. Okay, so you guys have plug that in the next step. And then you want to use your unit circle. Yep, yep. All right, so now when we're filling in these, remember with your tangent, what your values are. So at pi over 6, it's root 3 over 3. Okay, at pi over 4, it's 1. And at pi over 3, it's root 3. Okay, so when we plug these in, the tangent of pi over 4 is 1, so we have 1 plus root 3 over 1 minus 1 times root 3, okay, which is just the same thing as 1 plus root 3 over 1 minus root 3. Okay, if you have to use the root 3 over 3, which you will sometimes, okay, you do have to get a common denominator, and you'll have to simplify that. And then you are going to need to rationalize. So to do that, you're going to multiply by the conjugate. Okay, so you're going to multiply by the conjugate of the denominator. Okay, so I want you to write that down and then go ahead and multiply. And then, Jaden, what is our conjugate? What'd you multiply by? Yep, 1 plus root 3 over 1 plus root 3. So you have to multiply by something equivalent to 1. So just make sure you multiply by the same thing in the numerator and the denominator. Okay, the denominators are going to be conjugates. So when you FOIL, 1 times 1 is 1. Here you're going to get negative root 3 and plus root 3, so those cancel. Root 3 and root 3, when you multiply, is going to be minus 3 there. Okay, but the numerator, those are not conjugates, so they're not going to cancel. So 1 times 1 is 1. On the inside, you get plus root 3. On the outside, you get plus root 3. Root 3 plus root 3 is positive 3. Okay, so we're going to simplify these things. So we have negative 2 in the denominator. Okay, and then 1 and 3 is going to be 4. What's root 3 plus root 3? 2 root 3. Okay, now we want this to be as simple as possible. So the first simplifying that we did is when we got here, we have to rationalize. Okay, and then here, you're going to have to simplify by reducing that fraction. So when you reduce, it's 4 divided by negative 2 plus 2 root 3 divided by negative 2. Okay, sometimes I think it's easier for you guys to see when you split it up, but you can do the same thing from here. You're just dividing both by negative 2. So you're going to get negative 2. And then don't forget, these cancel, but you still have that minus there. So it's negative 2 minus root 3. Okay, what questions do you have on part 3? Feeling okay about that? All right, and then when you're starting part C, it's 11 pi over 12. So we've already converted everything to over 12. But the two largest ones are 4 and 6, and those only add to 10. Okay, so what this says here is if you can't find any values that add or subtract to the given value, now we're going to proceed to quadrant 2. What's the first value in quadrant 2? Two pi over 3 is correct. Okay, so now we're going to go to quadrant 2. Okay, so the first value would be 2 pi over 3. So now we're going to convert that to a denominator of 12. So if you multiply 3 by 4 to get to 12, 2 by 4 would be 8 pi. Okay, now do we have two values that will add to 11? Yes, 8 pi over 12 and what? 3 pi over 12. Again, the order that you add those in, it does not matter. Okay, but the 3 pi plus 8 pi is the 11 pi, and we're going to use the reduced value. Okay, so this would be pi over 4 plus 2 pi over 3. Okay, so I'm going to put up my formula so that you guys can use that to write out your next step, okay? So the addition formula, sine, cosine, plus cosine, sine. Go ahead and pull those in. have it did. Okay, so once you plug these in, you should have the sine of pi over 4 times the cosine of 2 pi over 3 plus the cosine of pi over 4 times the sine of 2 pi over 3. Okay, so Gabe, what'd you plug in for the sine of pi over 4? Okay, nice. And then, Kristen, what'd you get for the cosine of 2 pi over 3? Yeah. So this is pi over 3. This one is going to be 2 pi over 3. And when I'm doing this like without my calculator, without this, I do like to write down what my point is. So for this one, it's going to be negative 1/2 root 3 over 2. So we're going to plug in the negative 1/2 here. And the cosine is also root 2 over 2, just like the sine. And then the y-coordinate is going to be root 3 over 2. Okay, and then you're just going to multiply. The negative you can keep on top. So negative root 2 over 4. Don't forget 2 times 2 is 4 on the bottom. Okay, and it doesn't matter which one you write first. Okay, when you see the answer, generally whatever is positive will go first. So you would see this as root 6 minus root 2 over 4. If you have negative root 2 plus root 6 over 4, that is the same thing. Okay, so that is okay. All right, and then we're doing more prove the identities. So it's really imperative that you're showing each step clearly. So you're going to start with one side. Today, that's going to be the side that uses your addition and subtraction formulas. Okay, and then you're going to use these logical steps to prove it's true. Okay, and just like we did yesterday, we're going to be justifying each step. Okay, and then what we're going to do is we're going to continue to write in columns. So for today, we're always going to start with whichever side has the addition or subtraction formula on it. Okay? All right, so we have the sine of x minus pi. Your first step is always given and what side you're using. So we're going to use the left-hand side. Okay, and then you would be using those formulas on the front side. So the formula for subtraction is the sine times the cosine minus the cosine times the sine. Okay, and your rule is just going to be the sine subtraction formula. Okay, and we can abbreviate that. Just keep those in columns. Okay, your next steps are going to be the same for every single one. Okay, so you're always going to do substitution. Okay, with values from the unit circle. After that, we're going to multiply. Okay, and then after we do that, sometimes you subtract, sometimes you add. So we're going to look and see what we have. so when you're substituting, if you have pi, just think about where that is on your unit circle. So pi is right here. That point is -1, 0. So when you're doing the substitution, this is going to be the sine of x, and then the cosine at pi is -1 minus the cosine of x, and then the sine of pi is 0. Okay, sine is the y, cosine is the x. Okay, now we're just going to multiply. So sine times -1 is the negative sine of x. Anything times 0 is just going to be 0, so it's -0. Okay, and then so when you subtract those, you get the negative sine of x. Okay, and I don't care for the last one if you put subtract or if you want to put simplify. I would be fine with that as well. You are just subtracting the 0 there. So with these formulas, a lot of them have a pattern to them, which is kind of nice. So for B, we're going to start off again with our side that has the subtraction formula. So we're given the left-hand side. Okay, our subtraction formula for cosine is cosine cosine plus sine sine. Okay, so cosine cosine plus the sine sine. So sometimes I do that and write it down like that. Okay, so we're doing the cosine subtraction formula. Okay, and in this case, we have 3 pi over 2 and t, 3 pi over 2 and t. Okay, again, your steps are going to be substitute, then we're going to multiply. Okay, and then we're either going to subtract or simplify. Okay, so when you substitute, think of your unit circle. 3 pi over 2 is right here, so 0, -1. The cosine is your x value, so when you substitute, okay, you're going to have something times the cosine of t. You're going to plug in the 0. Okay, you're doing the substitution. Plus, you're going to substitute your y value. So your y value is -1. Okay, and then see if you can write out the last 2 steps from there. All right, so then you should have got 0 minus the sine of t, and then when you subtract, it's just the negative sine of t. All right, any questions for me on those? All right, for part C, remember for these, we always want to start with the side that has the addition and subtraction formula. And this one's a little tricky because you do have subtraction on this side, but look at all of your formulas. If you have the addition and subtraction formula, you always have parentheses. Can you guys see that there? I always have parentheses. So this is not a subtraction formula. This is the side with the subtraction formula. It's in the numerator. Okay, so this time we're going to start with the right-hand side. So we have the sine of x minus y over cosine of x cosine of y. So I know that one can be a little tricky. So given the right-hand side, okay, if we do the sine subtraction formula, we're going to get the sine times the cosine minus the cosine times the sine. And then the denominator stays the same. Okay, so we use the sine subtraction formula. Okay, now the mistake that some people make here is they try to just cancel out these and cancel out these and then write sine of x minus sine of y. But that's not what we're trying to get here. That's also not mathematically correct. Okay, you can't cancel just only these and only these because of that minus. What you can do is you can divide each term by the denominator. So you could divide the sine of x cosine of y by the cosine times the cosine. You can divide this by the denominator. And you can divide the second term by the denominator. Okay, and you can just say divide each term. You can also say divide each term by the denominator. Okay, we're splitting it up so that we can divide. And then when you do divide, now you can cancel these out because the value in between the operation is times, okay, not the minus anymore. So when those cancel, you have the sine over the cosine of x minus, here the cosines are going to cancel out. So you have the sine of y over the cosine of y. And a lot of you are doing a really nice job of making sure you write your variables out. You do need to make sure you do that. All we did here is we divided, or we could say simplify. So we divided those to make 1. And then, of course, we can change these into the tangent of x minus the tangent of y. What's the reasoning for that? What do we call that one? Yeah, good. Okay, so we're going to use your reciprocal identities there. Right, and that is your assignment for 7.2. Again, just notice those first ones are only the even. Okay, the 4 through 10 even. Chapter 7 does tend to be one of the more difficult chapters, so the more practice you can get in, the better it's going to stick when it comes to that first quiz.